Yeah, just like Larry Ellison, tell me next slide, please, and I'll switch the slides.
Next slide.
Yeah, next slide.
Next slide, please.
Yeah, next slide, please.
That's
okay,
what he says.
so
that's what he says. Next slide, please.
Yeah.
That's his thing.
Can everyone see this?
I am sure they can.
Okay, excellent. So yeah, sorry folks for the extra headache there. So let me talk a little bit about what Vexata brings to the enterprise storage market. So essentially, we have two storage systems. One which is an all-flash array, and the second one which is an all Optane array, probably the only one of its kind.
Wow, you got an Optane array? Wow, I didn't know that.
Yeah. So what you see is, kind of performance that you get out of either of those arrays is in the order of, millions of IOPS. So let's say 6 plus, maybe close to 7 million IOPS, and then 70 gigabytes per second. The flash array can go to larger capacities in the order of 175 terabyte today, and soon enough, about 450 terabyte in the future, right? And that is the flash array. Then the Optane is much smaller, has much better latency characteristics, as you can see, right? So what we bring is not just high performance, but we also bring a number of enterprise class storage features. The basic ones such as HA, NDU, we have those RAID 5 and RAID 6, and also some of the more important features that would be essential for Oracle database and rack environments, which is snapshots and clones, encryption. These are kind of features that are very important for Oracle users. So, fully featured storage array, extremely high performance, but importantly, we support fiber channel protocol, which is what most people use. Fiber channel transport is what most people use for Oracle and Oracle rack applications. And also, interestingly enough, we are probably the only storage array that can support NVMe over fabrics pretty much on the same array as in the fiber channel as well. So we have that, and we also have support for all the operating systems. So we don't need any host site changes when customers deploy our array. We can support Linux, Windows, and ESX. Unlike our competition, which largely, if you look at the newer NVMe or Fabrics vendors, they'll only support Linux. And we'll go into why that is the case, but we are able to support pretty much every operating system without any changes to the host. So that makes us very attractive for a variety of applications where, of mission critical nature such as Oracle, SAP, and so on, where the host changes are not allowed. So move to the next slide, please, Galan.
Yep.
Yeah, so this is the array that we have. It's a 6U box with active controllers, and there are no single points of failure anywhere within the array. The way storage is consumed by our customers, we have what are called enterprise storage modules, or ESMs as we call them. Each ESM holds 4 PCIe NVMe SSDs, and our customers can start small with, let's say, 4 ESMs in their array. And as their needs, capacity and performance needs grow, then they can plug in more ESMs to get to higher capacity and higher performance. Now you'll see that this feature that we call in-box scaling is essentially going to be very interesting as we show you how Oracle can be scaled with the Vexata array. Next slide, please. Yeah, so this slide builds out. So I'll talk about the storage infrastructure needs for the various Oracle workloads, right? That our customers deploy. So yeah, just do that. Yeah. So first off, many of our end customers obviously use Oracle database for mission critical transaction processing. And for example, one of our customers is using it for payroll processing. And as they add more users, one of the things that they were seeing with other arrays was that the latencies were much higher than they were not scaling on the IOPS. So the first and foremost requirement is that you need to be able to scale IOPS while retaining the low latencies. That's for transactional use cases. And then there are the analytical use cases. While a lot of analytics frameworks are in place today, that go beyond Oracle, what Oracle offers, and we do see a lot of our end customers using Oracle for Oracle database for analytics as well. So these require much higher bandwidth so that they can accelerate the queries and the insights. So that's a big requirement in addition to the IOPS and the low latencies. Number of our end customers are now resorting to using virtualized workloads, using ESX to essentially virtualize Oracle. So these customers need to consolidate multiple databases because their database needs are growing. As they become more and more digital, there are more databases, and they don't want to spend too much on Oracle licenses, so what they end up doing is consolidating multiple databases on fewer servers and consolidating the storage into fewer arrays so that these arrays can scale better and offer much higher performance. So that's a big requirement for the storage infrastructure. And then finally, one of the interesting paradigms that's showing up today is hybrid transactional and analytical databases. It's called HTAP or HOAP, depending on which analyst is writing about it. But these applications, they need ultra low latency so that on the production database, while the OLTP transactions are running, they want to get to real-time insights as quickly as possible. So this leads to very stringent requirements, on the storage array. In fact, if you go to the next slide, Yalam. Okay. So here, 451 folks talked about the importance of HOAP. And it's a really real-time analytics and transactional processing database systems. What they see is that, come 2021, 30% of all the OLTP systems will need to have some sort of real-time analytics that they can support. Now, if you look at the kind of storage requirements for HOAP workloads, you're looking at pretty much, a slew of, high performance requirements, high IOPS, low latency, high bandwidth, and so on, all probably, in something that gets integrated very well, right? So this is something that Vexata is closely following, and it results in much higher requirements that we can satisfy with some of our, NVMe arrays. So if you go to the next slide, Yalam.
Done.
There are a number of choices that customers have in implementing essentially different workloads, OLTP, OLAP. Now there's consolidation, and there's also the HTAP that I talked about. So today you'll see that there are a variety of choices that end customers have for implementing all these different workloads. There are the single instance databases that essentially are maybe what we have seen as 20, 30 terabytes of Oracle. What the customers need is to deploy a single database, and they want ultra low latency out of it, and they want the entry level storage cost to be as low as possible. There are a variety of choices for them. And then there is the consolidation workloads where you have the monolithic arrays, the big ones that scale out, such as the Hitachi G1000 series. These are really good arrays which have a lot of features. They go up to, I think, 4.8 million IOPS and so on, where multiple Oracle workloads can be consolidated. So need for scaling to high performance, high capacity is a huge need for consolidation. And then, of course, there are the integrated systems, such as the ones from Oracle. The Oracle Exadata is the highest performing one of its kind, which is very suitable for HTAP applications. You have high IOPS and bandwidth and ultra low latency as well. So you have a variety of choices, and if you build this out, Vexata essentially caters to each and every one of these models, and I'll go over all of these in the form of solutions in the next few slides. But before I do that, essentially across all of these different storage infrastructure options, what you'll see is that the common underlying theme going forward is going to be PCIe NVMe SSDs. So next slide, Yalam. So why is NVMe important, right? I mean, for us, on the storage side of things, NVMe SSDs and front end, back end NVMe as we call them, and then the front end NVMe over fiber channel is very, very critical, because as Gartner is predicting, 50% of all external controller-based systems, which is essentially the all-flash arrays and all the other arrays, would move to one form of NVMe or the other. They either will use back-end NVMe flash drives or front-end NVMe over fabrics, or essentially both, right? So over the next few slides, I'll go over what is the difference between these two, and how Vexata essentially caters to pretty much both back-end and front-end NVMe, and how we have the only architecture that potentially is going to be useful for Oracle rack and database use cases. So yeah, you can scroll forward. Yeah. So here, first of all, what is back-end PCIe NVMe versus front-end NVMe, right? So this distinction should be pretty clear. So there are a number of storage systems that essentially have NVMe flash in the flash SSDs, that they use for storage, and they use SCSI connectivity of some kind using fiber channel mostly, or iSCSI to talk to the host. I call those the backend PCIe NVMe storage systems. And then they are the newly emerging NVMe over fabrics protocol, which essentially enables the host to connect to front end to the NVMe drives through a end-to-end protocol that is ultra low latency and can scale to really high bandwidth as well. So essentially, NVMe over fabrics can run on Ethernet transport or fiber channel, and is able to connect directly to the NVMe drive. So these are the two kinds. So if you go to the next slide, Yalan, it talks about why NVMe SSDs are important. So first off, these SSDs have much higher performance compared to SATA and SAS. So if you look at let's say Micron SSDs that I have for the same capacity drives, 3.2 terabyte drives, you can see that the IOPS and the bandwidth that you get out of an NVMe SSD is going to be 3 to 4 times higher than, let's say, a SAS SSD. So the reason for this is that NVMe has much more queues, it has 64,000 queues and much wider interfaces and so on, that enable the flash chips to be accessed at a much faster rate for both reads and writes compared to SAS SSDs. Perhaps the most important feature of the NVMe drive is the latency characteristics. Even though here the latency number is just slightly lower compared to SAS, what really happens is that at really high performance, when you stress out the SSD quite a bit, what happens is that the latency of a SAS SSD is going to be much worse than that of NVMe. So what NVMe brings is more consistent latencies and really high IOPS. And also, it is becoming the storage SSD of choice for both server and storage arrays. And so SATA is generally used in servers, and what we are seeing is that NVMe is replacing SATA in the servers for storage. And SAS is generally used by most of the arrays for storage, and we are seeing SAS SSDs getting replaced by NVMe. All this leads to economies of scale and lower pricing, especially with the 3D NAND flash that is coming on pretty soon. So if you look at the performance of a single drive in here, it's 445K IOPS in this case, right? But if you look at the performance of a storage array which has, let's say, 25 of these drives, you would expect, let's say, 10 million IOPS as the number that it should be able to provide, right? But that's really not the case. You see that most of the arrays top out at 200K or 300K IOPS, while they should be capable of 10 million IOPS. Now, why is that the case, right? I mean, that's really what I show in the next slide, right? So if you take a look at the architecture of these storage controllers, these could be any of the incumbents, right? I mean, they they do a really good job of creating shared storage services. Right? If you take the I/O controllers, they enable sharing of volumes by multiple servers, which is really what is needed for an Oracle rack sort of an application. Right? But what they also don't do very well is that they're not able to process all the data that's coming from the SSDs in parallel. Right? So only if you're able to access all these SSDs in parallel, you can get to the really high performance that we are talking about, right? The multiplicative performance of multiple SSDs. So what happens is these I/O controllers are very, they're doing a lot of different things. They're providing the storage services, and they're unable to essentially do full justice to the performance of these SSDs. So they read them or write to them one at a time, and through very anemic PCIe switches. So what happens is that due to the lack of the parallel processing, these NVMe SSDs are very poorly utilized. And as a result, what the servers end up seeing on an aggregate is something like 200K IOPS, which is less than what even a single drive is able to provide. And also they see much higher latencies as well. So really the only way to solve this problem is to have parallel access to all the SSDs in one shot, right? And if you go to the next slide, that's exactly what NVMe over Fabrics did. So essentially, what NVMe over Fabrics is all about is that the host can directly access all these SSDs in parallel through multiple NVMe over Fabrics, connections, interfaces. But what really happens is that the I/O controllers, as you can see, they're bypassed completely when these SSDs are accessed. So the reason the I/O controllers are there is because they provide shared storage services. For example, if you want to take snapshots or clones across your data, or if you wanted to essentially create encryption, of all the data from various sources, right? You need the shared storage controllers. They're there for a reason, but it's almost what these newer architectures did is essentially they just eliminated the I/O controller from the data path, and as a result, there are no storage services available. This is almost like if your leg is hurting, it's like amputating your leg instead of trying to solve the problem, right? That's exactly what these newer architectures did, and as a result, they don't have great storage services, even though they provide excellent performance. And one of the other artifacts is that if you take a look at the host agents, they are very custom agents that these arrays need because they don't have storage services inside the box. For example, if they need to replicate across, an active pair of controllers, what they need to do is provide the replication services in the host. And these days, Linux multipathing is not fully ready, so the multipathing is done by these host agents. So essentially, you don't want a custom host agent because what that means is that even though you can support Linux, you pretty much cannot support ESX or Windows. Now, this becomes a huge problem when you're trying to virtualize Oracle and you don't have ESX support. You're pretty much in deep waters because you cannot support ESX, right? So while these architectures do a good job of making the SSD access parallel and bringing the data out of the SSDs, what they don't do really well is provide shared storage services. So you need an architecture that essentially can do both, provide shared storage and high performance at the same time, which is essentially what we did with Vexata. So what we did was we accelerated the I/O controllers while we read out the data in parallel from all the SSDs. So we don't use PCIe inside, we use Ethernet, and that enables us to read out all the SSDs even faster. So there's parallel access to the SSDs, and the data flows through the shared I/O controllers, which perform a lot of accelerated services that essentially are needed for an Oracle rack sort of an environment. By doing this, by essentially eliminating the bottlenecks that existed in the traditional architectures through acceleration of the I/O services, we are able to provide much higher performance for shared storage workloads. So you'll also see that we don't need any custom agents in the host. So that means we can support ESX, Windows in addition to Linux. We also support, in addition to traditional fiber channel, NVMe or Fabrics, and and any of the other protocols as well. So that's the power of Vexata. Right. Moving to the next slide. So yeah. So if you can build that out, Yalan. So what we see is interesting for our end customers with NVMe or Fabrics is this. We have, with Vexata, we have pretty much eliminated all the latency that lies within the target, so that we are anywhere from, anywhere in the order of 100 times faster in our storage stack, even with SCSI protocol, being used end to end. What NVMe brings to the table is that it accelerates the host side a bit more, so that we believe that it will reduce the latencies down by 2 to 4x, and end-to-end latencies then will significantly improve for an Oracle sort of an application. And this becomes fairly important when you deploy something beyond flash, like an Optane SSD inside your array. And as you can see, the latencies, any latency that you have in the path matters significantly. And what we managed to do at Vexata is to essentially eliminate all the latencies in the path, so that we can get to much higher performance. Right. So if you go to the next slide, I summarize why Vexata NVMe for Oracle. So essentially, we provide both shared storage services as well as really high performance, and which is the crux of what you need to scale Oracle. So with that, let me move into the solutions part that we have. So there are a number of different solutions benchmarking that we did within Vexata. And you can build out this slide, Yalan, to show how we scale Oracle. Now, what I show here is this. In the experiments, in the solutions that we did at Vexata, we started with 2 servers, and these are 2 dual-socket Xeon servers. And we started with a small Vexata array which has 4 ESMs. So when our customers, most of our customers in the very basic configuration potentially use something like this. And if they want to scale the compute side of Oracle, they just add an extra server. And in the case of a Vexata array, if they want to add extra performance to the array, all they need to do is add few more enterprise storage modules. So as you can see, as we add 4 more modules, we get 30 terabyte more capacity, 1.5 million more IOPS, and a bandwidth of 16 gigabyte per second that is extra over the first configuration. And you can scale this further to 100 and 175 terabyte and hit around 70 gigabyte per second of bandwidth and 6 million plus IOPS. So what this provides is a very, very simple way to scale Oracle workloads. So you can scale your databases in a very simple way by adding servers into your Oracle rack, and you can scale the array just by non-disruptively adding more Ethernet storage modules into the array. In fact, the application can continue to run as our customers add these ESMs. There's an automatic load balancing that kicks in and takes the performance to much higher levels.
So all of this can happen online? So all of this can happen online?
It's all online, yes.
Wow.
It's completely online, yeah. So many of our customers, in fact, the way they start out, they start small and probably have a single instance Oracle database. And after that, as they consolidate more and more databases, just add more servers and just add more enterprise storage modules, and they can take the capacity up to 175 today. And soon enough, 450 terabyte that should be coming out in the first half of next year. So all of this happens in a 6U box, so you don't really need anything else. No cables, none of those things, no additional rack space. So in the next slide, actually I show some of the actual Oracle numbers from Oracle that we captured that shows how nicely the whole thing scales. So if you look at what we did here, so we started with 4 ESMs and moved to 8 and 12, and we used 2, 3, and 4 servers to show how Oracle rack scales. at a database level. So you can see that the latencies that we're able to get pretty much scale linearly. So you can start with as low as 1.5 million with 2 servers and hit something like 4.5 million IOPS out of 4 servers. So you get a linear scaling in IOPS. At the same time, your latency, right? I mean, it remains very low. I mean, most of the latencies you can see are much below 500 microseconds, right? And we maintain the ultra low latencies while we are scaling Oracle out. So this is one of the interesting and important ways in which we can scale out for performance. Now, if you contrast this to what our competition does, so let's say, I'll get to that. So if you go to the next slide, so this is a bare metal solution that we had. We also did the same solution with virtualized workloads. And interestingly enough, even if you deploy Oracle on a VM, it doesn't result in any latency hit. You're seeing ultra low latencies and ultra high server efficiencies because you can consolidate multiple VMs onto a fewer set of servers. So if you go to the next slide, that shows how how the performance will scale with virtualized workloads. So we started out with a single VM that was running an OLTP workload, and it hit 500K IOPS and about 150 microseconds of read latency. And we added more and more OLTP VMs and some analytics, OLAP VMs as well. And you can see that after we completed all of that, the performance went up to around 2 million IOPS and 20 gigabytes per second. And really, the latencies didn't go up much. They just went up barely, about 70 microseconds or so on the read end. So if you notice what we did, we have high IOPS as well as really high bandwidth and ultra low latency, and this lends itself to HTAP sort of use cases, which are generally addressed by the engineered systems. So let me go into some of the HTAP reference design that we have next. So if you go to the next slide. Before that, so this slide just shows you how we compare against some of the popular all-flash arrays and what you need to do to scale your Oracle workloads using the existing all-flash arrays. If you notice, each time you need to add, let's say, 25 terabyte, you need to buy an entire new array, and which delivers, let's say, around 200K IOPS and 6 gigabytes per second. So you also add more power, and more rack space, as you can see. In the case of Vexata, you just don't need to do anything. You just add the 25 terabyte, you get 1.5 million more IOPS, right, and 16 gigabytes per second. So this is a very cost-effective way because our ESMs don't cost much because they're pretty much, just a bunch of drives. While in the case of our competition, you need to buy these storage arrays, and it leads to about 4 times higher costs compared to just adding, ESMs. So a lot of reason why Vexata should be used for consolidation of some of these Oracle workloads, right? And if you go to the next slide, the holy grail of for us is the HTAP reference design, and we have come up with reference designs that we provide to our end customers with Lenovo and Supermicro servers. What this is an end-to-end design with storage and networking, all of it, the servers all built in, and we provide a blueprint for our end customers to implement so that they can get to the kind of performance that you see out here. So if you build out the slide, so what you'll notice is that each of these servers is capable of nearly 1 million IOPS. And we managed to get 4 million out of 4 servers at ultra low latencies, let's say 500 microseconds. And we also are able to get to massive query performance, which is what is needed for HTAP use cases. So the kind of performance that you see out here, and obviously it's also a single reference design that we will support. So this lends itself to comparisons, against the engineered systems. So if you go to the next slide, I'll show you how we perform in comparison to the engineered systems. Right here, what I show is an 8-node Oracle rack with 8 dual-socket Xeons and then 2 Vexata arrays. So each of our arrays has 2 I/O controllers, each with a single CPU in them. So essentially, we have 4 CPUs in our storage controllers for this particular configuration, while the engineered systems, the highest end ones have 28 CPUs built in. So that's 24 fewer CPUs in our case, which means much lower hardware costs.
So 24 fewer CPUs, and you get better results?
Yeah, we get better results. So if you take a look at the results,
wow.
It's 8 million IOPS from these 2 servers, and we are we are actually hitting the server limits with 8 million. We can actually potentially go to even higher numbers, something like 15 million IOPS. But we hit 8 million IOPS with 2 servers. I mean, with 2 arrays and 8 servers, which is at least 25% better than the engineered systems. But the most critical part here is this. The engineered systems actually triplicate data, which means that your storage efficiency is going to be very low. I mean, we implement RAID 5 and RAID 6, so we can get to 2.5 times higher utilization of the flash. And this becomes very important, not just because the cost of flash is still high, it's also because we don't have any storage license costs when people implement Oracle rack the way I've shown. The engineered systems actually cost quite a bit on the storage licensing, right? And with Vexata, there's no storage licensing cost. So if you look at all of that, and if you look at the bandwidth, which for this setup is going to be 150 gigabyte per second, that's not at all shabby, right? I mean, per controller, we're actually much better in terms of bandwidth, with our arrays. So whether it is at the lower end with very few ESMs or at the highest end with, let's say, 2 arrays put together to form an 8-node rack, we are going to be, the storage of choice for scaling Oracle, right? And so what are our customers saying? I mean, so let's take a look at some of the use cases quickly. So this one, if you go to the next slide, yeah. So here is one where our end customer was deploying Oracle for an OLTP application. This is a multinational company in India. It's one of the biggest business companies out there, enterprises, and they had trouble with their payroll processing because it would take 3 days. And they were using a hybrid array. It's a really expensive hybrid array, but they couldn't pin their database to flash after a certain size because it just outgrew the size of flash inside the array. So they were seeing very high latencies, and all they did was to put in one of our smallest arrays into the mix. They didn't change anything else, and all of a sudden they saw the latencies come down, by 6x, right? And interestingly, all they need to do is upgrade their network and add more ESMs if they need to get to even higher performance, or if they want to consolidate even more workloads. So this is an OLTP use case. The next one talks about a consolidation use case. This is before Vexata, this company had multiple physical servers running Oracle. Oracle license costs were really high, and they wanted to consolidate to use fewer servers, so they went to using VMs, and they knocked down the number of servers to just 2, or from 6. They had 6 and they moved to 2. And also they had multiple arrays that they consolidated into a Vexata array. And what they managed to do was get much higher performance for these VMs, much lower power and rack space and everything else. And interestingly, now they want to add more VMs, and each VM takes up about 10 terabyte of capacity. All they need to do is non-disruptively add the VMs, more servers or whatever, more VMs, and then they just need to add more ESMs in the back so that they can non-disruptively scale to let's say 8 VMs or maybe 10 or more. So it's a very, very interesting use case of consolidation. The next one talks about consolidation at a much larger scale, which underscores the power of Vexata as a general purpose array. So this customer is one of our biggest design wins to date. So this is a media giant that really had two tiers of flash. They had one tier that was ultra high performance flash for custom metadata, and then they had a private cloud where essentially there's a lot of MySQL based content processing and Oracle databases all mixed up. So the problem that they had was first they needed to maintain two different tiers, which meant higher cost and complexity. And also they ran into a noisy neighbor problem where the Oracle workloads were not serviced very effectively because of the MySQL database collisions, right? So essentially what we did here was to eliminate all tiering by consolidating performance and economy into a single Vexata tier. And the noise from MySQL workloads also got eliminated because in a very simple way, we are line rate at 8 gig and 16 gig. I mean, that's incredible, right? I mean, so the network that they had inside the SAN network that they had was 16 gig, and we are pretty much line rate at 16 gig, and even line rate at 32 gig for reads. So they did not have any bottlenecks within the array, and they managed to consolidate all these different workloads into a couple of high performance, economical arrays from Vexata, right? And then finally, I'll touch upon HTAP workload. So we are pursuing this opportunity at a company that had a pretty difficult problem. So essentially, they had a incumbent all-flash array that they use for a production database, and they were doing ETL processing to move the data out for reporting and reporting use cases and analytics into a very expensive engineered system that was running Oracle BI. This whole process was prone to errors, and they had a number of compliance issues that they had to deal with, not to talk about all the networking that they needed and extra storage costs and so on. So we are looking into supplying a single storage array to them that can cater to pretty much both workloads at the same time. They can run the real-time analytics for HTAP on the same production database, thereby eliminating all the compliance issues that they have been having, all the errors and so on with the ETL processing. Right? This is an emerging application for us, and increasingly as the enterprises get more and more comfortable with Vexata arrays, they consolidate some of these other workloads also into our array. Right? So this is what I had, and just to summarize, go to the last slide. Yalam. Yeah, so what we offer with Vexata is essentially the highest performing NVMe storage for scaling Oracle. We have done about 30 proof of concepts in the last year or so with our end customers. We'd be very, very happy to do more POCs. If you are interested in doing POCs or just want to look at a demo of all these features and various Oracle solutions, please reach out to us, and we'll be very, very happy to serve you. Okay?
So a POC
Thank you very
in
much.
this case, thank you, Venky, and everyone. If you have questions, I keep taking notes. Feel free to keep entering them in, and now Venky is going to answer our questions. But I had this question also noted. So for a POC, how does that look? You basically do a migration of an existing system to Vexata storage,
Yeah.
and so it involves a migration, basically. That's it.
Yeah, so what our customers end up doing is essentially take a backup of their existing database onto a Vexata array, and then they pretty much mirror, the same workload that they are running. So some of them have the real RAT or whatever they call it, right? So they have that to essentially emulate their production database, or in some cases they take the most difficult queries that they have out of their databases and try to run it on our array to see what kind of performance improvements they get for analytics, right? In fact, many of our design early wins have been like that, so they ran pretty much ran a subset of their production workloads on a backed up database and they saw the incredible performance that they were getting, right? And they moved forward.
Okay, so let me move to the questions. Let me bring myself back to the picture. So if you have questions, please answer them. In the meantime, I'll ask the ones that I received. Well, one question I received was, that's a hot topic, maybe not literally related to what we talked about, but it's sort of related because you mentioned it. How does the Oracle licensing work if the database is virtualized, if it's in a VM? Because there's a lot of rumors about that even I heard. Like it used to be the same. Now did this change?
From what I understand, sorry.
So is it changed now?
No, from what I understand, at least, I mean, I have to check this again, but there seems to be no difference in how these two are implemented. So essentially, a number of CPUs is what they take a look at, right? I mean, 0.5 times number of CPU times, 23,000 or something for the basic license. I think that still remains the case. What our end customer sees that, they don't really need too many cores with the Vexata array, right, in order to sustain the performance.
So the number of cores reduced. Okay, so the number of cores reduced. It's essentially you can run multiple VMs on the same server, bare metal server. Okay, so here is another. Well, actually, I got this question. I had this question, and I'm also receiving this from the attendees. So, how does Optane 3D Crosspoint help with scaling Oracle? And there is also these rumors about 3D Crosspoint memory slots, like actually the devices like chips you put on the memory. I don't know what they call it, the RAM slots. Like, what's the feature there?
Yeah, so we work very closely with Intel. By the way, we are Intel capital funded, and and that's,
you are? I didn't know that.
Yeah, Intel is a substantial investor in our company. And the reason for that is they wanted to see their 3D Crosspoint SSDs and later on the DIMMs when they come out being utilized by storage vendors for the highest performing storage of its kind, right? So in fact, we built our company around 3D Crosspoint. So it was way too early when we started out, and they were not available, so we went with Flash. But we do believe that 3D Crosspoint is going to be fairly prevalent 2 to 3 years out, right? As the densities improve, Intel is planning to bring out, let's say, about 4 terabyte SSDs with 3D Crosspoint. What we see is this: Oracle random access, essentially OLTP, is all about accessing data at the lowest latency possible, right? So what 3D Crosspoint brings is essentially much lower latencies. We are seeing something in the order of 30 microseconds, on the array when we use Optane drives inside our box. So we have a 15 terabyte box, right? That can be used for OLTP use cases. In fact, we have a very major payroll processing customer in the East Coast who's planning to do a try and buy of the Optane array, because for them, they just need to get to the fastest random access possible for Oracle, and that's really where we see the most interesting use cases for Optane. Optane also, by the way, can significantly ingest data. The write performance of Optane is much higher than Flash, so we do see that it could get used, especially for the high-end AI, ML sort of use cases, where the capacities will be low, let's say 20, 30 terabyte, but the ingest rates could be something in the order of 35 gigabytes per second, which is something that we sustain, by the way. 35 gigabytes of writes and 50 gigabytes of reads.
Another question is, you mentioned reference designs. So what kind of reference designs do you offer? Do you help with the implementation, and what kind of reference designs do you have, or for what kind of workloads?
Yeah, excellent question. So as I mentioned we do have a variety of Oracle rack reference designs for 2, 4, and 8
Yes.
node Oracle. But beyond that, we also significantly take a look at all the important databases and analytics platforms. And we offer, for example, a SQL Server, DWFT reference design. And we have the highest performing DWFT implementations that are used significantly for, analytics and reporting. Right, so we have those reference designs. Those are certified by Microsoft, by the way, and we have several papers out there, in the open that you can take a look at. And we also have the highest performing SaaS analytics reference designs. So our storage is a SaaS certified storage. So with 8 nodes, similar to an 8 node Oracle rack, we created an 8 node SaaS reference design that pretty much, beats everyone by an order of magnitude in terms of performance. So it's a SaaS certified reference design. It's available on the SaaS website that our end customers can go and deploy for their analytics needs. And we have a few more. We have file reference designs with IBM Spectrum Scale and so on. But essentially, we focus on database and analytics.
Yeah. So the customers don't really have to try to figure this out. The designs are already there. They just have to implement it.
Yeah, that's right. We just provide the entire blueprint, so what networking to use, what server.
Do you help with the implementation? Do you help with the implementation? Do you help with the implementation too?
Yeah,
we do. Do the implementation?
We do. So in many cases, most of our early customers want us to help them tune their databases or whatever else, right? And in the case that they need the reference design, we provide it to them. Otherwise, we do help with tuning, essentially their host sides, because there's not much tuning or no tuning needed on the server side of things. I mean, on the storage side of things with us.
Okay, so it can be a turnkey service where you do everything, or you engage with the customer the way they want. Okay, got it. That's very similar how we work. So you mentioned arrays, and do array management? Multiple arrays can be managed in S1 array. Do you have something like that where you offer scale-out product or service for that?
We have that feature coming in early Q1 of next year. We have a number of our end customers. Yeah, number of our end customers who want to manage multiple arrays as a single array, and we can do that by management, essentially having a single pane of management across multiple arrays.
So Michael had a comment here. Okay, so it's about virtualization environment. So basically, what Michael says is Oracle treats VMs like regular machines, which is fine. That's not the benefit anyways. So finally, now this has been on several people's minds, and it's been on my mind, and we talked about this. Now, with the move to the cloud, like people move to the cloud, a lot of companies move to the cloud, Oracle pushes to the cloud. Do you work with cloud vendors? If we are in the cloud with our workloads, how do you fit in there?
Yeah, that's an excellent question. In fact, that's something that we are working on for our next generation. So essentially, when we started out, cloud was not that big, 4 years ago, but now we have seen that the cloud is something that's pretty big for us, and pretty much all storage vendors have to cater to it. So we do work with the cloud service providers. Today, we provide them with the Oracle rack reference designs and other reference designs that they can implement. But in the near future, we are also coming out with an implementation that's pretty much software-defined storage. So we can use plain vanilla servers with SSDs filled in them, and then have the Vexata I/O controllers at the top of rack, and provide much higher performance than what the service providers today get with other implementations. So this is something that should come out.
So this is going to be just software.
Yeah, it's pretty much in a software-defined storage, and we'll be able to provide much higher performance than existing implementations.
The actual cloud provider.
Yeah, so we are working with some of the cloud providers. Oracle obviously, it has its own cloud and so on, and they offer Exadata in the cloud. But certainly, if some of our end customers want cloud versions of what we have built, then we'll be working with some of the service providers, to provide software-defined storage for them.
Okay. I think that's pretty much all the questions that we have. Anything else you want to add, Venky?
No, it was fantastic talking to all of you. Hopefully this is something that was interesting, and I do hope some of the people listening in would be intrigued enough that they want to learn more about Vexata. So certainly feel free to reach out to me or to the information I provided. So I'll send you. I already sent you the slides, so you can do a PDF of that, Yalam, and send it out to
yes, I will.
The folks.
And
maybe some of them.
I received a few questions about this. I'm going to email the slides and the recording of the webinar to everyone who's signed up. So no worries.
Okay. Thank you very much, Alan.
All right. Thank you for your time, and thanks everyone. I appreciate I appreciate that you're all here, and we're going to see you in an upcoming webinar. And if I don't see you until the end of the year, I wish everyone a happy holidays to you too, Venky, and a happy New Year.
Yeah, happy holidays and happy New Year. Thank you. Yeah.
Bye-bye, everyone.
Bye.